Yo, how's it, man? Okay, we need to show that k is rational if p equals 3 and k is this big mess over here. So all we're going to do is we are going to grab that 3, we are going to pop it into those p's there, we're going to sub it in. So nothing else about the structure changes, and we pop those 3's in there, and then we start to simplify. So 3 plus 2 is 5, 5 divided by 5 will give me this 1 over here, and then 3 divided by 3 will just give me another plus 1 essentially there. Square root of 1 is just 1, and 1 plus 1 is 2, which is definitely rational. So having a look at our number system quickly, we can see that 2 is inside the natural numbers, the whole numbers, the integers, as well as the rational bubble, just to reaffirm that it does fall within the rational scope. And just wrapping this question up, our 2 marks come from this simplification step as well as the answer for k over there. And as we go, I love to triple check myself as I go. Just takes like 10 seconds to see that I simplified that right. And now we can move on to the next question. Carrying on with the number system, we need to determine the values of p which will make this real. Now I'm going to walk you through the logic behind this. We've got to model our answer according to 2 things. To get something that's real, I need to square root a positive number. So underneath this root over here, I want a positive number divided by a positive number, so that I don't get the square root of a negative and non-real stuff. I want that real stuff, my bro, you see. Okay, and then this p over here will quite frankly have no impact. I can put anything into p that I want there, and it will always be real. So we are going to ignore this part and just look at what's underneath the square root. So this 5 over here, it's already positive, so I'm not worried about that 5, I'm ignoring it. But this p plus 2, I want that thing to be positive. And also you see it's at the bottom of the fraction. I've got to watch out for undefined. I can't have something divided by 0, because that's not in the real number system. So how we model our answer is according to these 2 things. And mathematically speaking, if I want to make something positive, I grab it and I make it bigger than 0. Anything bigger than 0 is a fancy way of saying anything that's positive. And then we just yoink that plus 2 over there, it becomes -2, and there lies our final answer, which is where your 1 mark will come from. Coming up next, we have a pretty stock standard quadratic equation. And with the quadratic equation, I want to get standard form. So we're just going to move the 4x over to the other side as well as the 2. And you see that correct to 2 decimal places over here? That's a massive clue. It's telling you to use the quadratic formula. So once we move these guys over, the 4x plus 2, we want the x squared term first. So we're going to leave him first, and we're going to bring that 4x over, and it becomes minus 4x. We want him in the middle. And that 2 we want at the very end, and bear in mind it becomes minus 2 when you take it over. And if you've taken everything over, you left over with 0. And from there, we extract our a, b, and c values. And when I substitute into the quadratic formula, I like to leave like a skeleton of brackets like this, bunch of empty brackets, and you just pop in a, b, and c into those brackets, and then it's pretty much calculator work from there. And when you are typing into your calculator and you're hitting this hurdle over here, just do the positive one first and carry on with your square roots. Okay, so we just slap that in, press equals, we get this mess over here. I'll just press S to D so that I can get it to 2 decimal places as they instructed over here. So let's get that one written up. X equals 1,72. Now on your calculator, just press right, keep going right, and then change this plus to the minus over here, and that will give you your second answer. Slap that equals, and there's our second answer, minus 0,39. That's 7, we'll round this 8 up. And now we've successfully finished the question, having a look where your 2 marks come from. You get 1 mark for your substitution in this step, and 1 mark for the correct answers. This question will be testing quadratic inequalities. And with quadratic inequalities, same as before, same as with quadratic equations, I want that standard form. So we're going to grab this -21, move it over, and it becomes positive 21. And just make sure you maintain the right order, x squared first, the x in the middle, and the one with no x at the end, so we can start the process of factorization. So we start off the process of factorization by looking at the factor pairs of 21. Now 21 has two factor pairs, so I need to decide which pair to use. Now how I decide is I look at this number in front of x. I've got to add or subtract these two numbers to get that number in front of x over there. So I don't think 1 and 21 can do that, so we're going to use 7 and 3. And then I need to think to myself, how do I add or subtract 7 and 3 to get 10? Well, that's not too bad. You just say plus 7 plus 3. And with that plus 7 plus 3, we can formulate two brackets. Inside the first bracket, you'll just have an x plus 7. You see the plus 7 over there. And inside the second bracket, you'll have an x plus 3 taken from this plus 3 over here. And the inequality and the 0 will remain unchanged. Next up, we have to get our CVs. So our CVs are normally just the opposite sign of what's in the bracket, but the precise way you're supposed to get them is you look at factor 1 and factor 2 in your quadratic equation here, and you make each one equal 0 separately, and you separate them with the word or, and then you grab the 7 and you grab the 3, take them over, and basically solve for x. After getting our CVs, we're going to have to draw either a number line or a sketch of a parabola. I like to sketch a parabola because it creates deeper understanding. So I'm going to do quite a detailed Cartesian plane for the purposes of explaining this question to you. We can see here with the x squared, the number in front is positive. It's a sneaky little 1. So it's just going to be a stock standard happy face parabola. And I'm going to put my lower CV on the left. So I'll put negative 7 on the left and negative 3 on the right. And then to go a little step further and analyze this parabola. This parabola has 3 separate regions to it. So this green region over here is where it has positive y values. And this green region over here is also where it has positive y values. And then this little region in between negative 7 and negative 3, that gives me negative y values. And to properly assess which one we need to answer with, we look at this crocodile mouth over here. And that's saying I want the parabola to be bigger than 0. I want positive y values. And we are finally ready to state our answers. So from negative 7 to the left, how we state that mathematically is when x is smaller than negative 7. Then we're going to hit the word or, and we're going to state the other region. It's from negative 3 to the right. So it's when x is bigger than negative 3. And there is another way you can represent this answer, and it's called interval notation. And with interval notation, you start off with x is an element of, and then we always use round brackets for infinities. We're kind of saying it starts at negative infinity and it stops at negative 7 with this notation. And then we use the word or, and we open up a new bracket, and that one's going to go from negative 3 all the way on to infinity. It will go on forever. And wrapping this question up, your 4 marks will get delegated to the standard form, factorization, CVs, as well as your final answer. Next up for 5 marks is a surd equation. And surds are things like square roots and cube roots. And how we cope with these is the opposite operation of a square root is a square. So we square both sides. So we just grab the equation and square both sides. Now on the left hand side, this square cancels with the square root, and we are just left with what is underneath the square root at the moment. And on the right hand side, we're going to analyze this a little bit further. So if I'm squaring something, I'm multiplying it by itself. So I'm just going to duplicate that bracket over there. Then 2 times 2 will give you 4. And root x times root x just gives you x. Another nice way of seeing it is the root of x is the same thing as x to the power of a half. And if you multiply those two guys, you add the exponents to get like 4x to the power of 1, which is the exact same thing as 4x. And then once we have dealt with squaring both sides, we're going to get our standard form. So this little 4x over here, he needs to move over to the other side of the equation. And just remember when you do that to change sign. So over here it's 4x, when I move it over it's minus 4x. Now I've officially got standard form. Now we start the process of factorization. And to kickstart that process, 5 is a beautiful little thing. It's a prime number. It's only got 2 factors, 1 and 5. So I need to add or subtract those to get negative 4. And to get minus 4, I'm going to have to say plus 1 minus 5. And we can formulate our 2 brackets now. So our first bracket will be x plus 1, as we see over there. And our second bracket will be x minus 5, as we see over there. Okay, now we hit the old pisang split and solve, my bro. So we equate factor 1 to 0. or we equate factor 2 to 0. And then we just yoink that 1 and minus 5 over to the other sides of the equation to give us our two answers of x equals negative 1 or x equals positive 5. But with surd equations, you've always got to check your answers. So we'll start off by testing this negative 1 here. So how we do that is we revert back to the original equation and we kind of type it into our calculator like this. But instead of an x, you leave open brackets. And I'm going to put that negative 1 in that bracket over there. And if I press equals, I get math error. So something's not quite right when I'm testing that x equals negative 1. It's giving me math error. So it must be an invalid answer. So we come to this equal sign over here and we put a stroke through it. Now we're going to test out the x equals 5. And when I test it out, I don't sort of retype to my calculator. I just press left and then I replace this negative 1 over here with our other answer of x equals 5. And if I pop that in, I get 2 root 5 on the left hand side. Now I'm going to type this side of the equation into my calculator, leaving some open brackets where x is over there. And then I'll put my x value in, that 5. And yeah, you can see it gives me a 2 root 5 again. So when I test the x equals 5, it gives me the same thing on the left hand side and the right hand side. So that's working. So we leave it as is and we're officially done with the question now. And the 5 marks in this question come from every single step over here. Next, we have an exponential equation. And I know that because of where x is. It's in the exponent. So if we take a step further to analyze this, so what I'm seeing here is two terms with x, which tells me I need to factorize. But before I factorize, I need to split these guys up. So we have a look at our powers over here, and we're going to split them up with exponent law 1, but the reverse version of it. So I'm going to split it up into two separate bases, and the first one will have this power, and the second one will have that power. So if I split this up, it's just going to be 3 to the power of x times 3 to the power of 1. That plus will stay there, and I'm going to split him up at the same time. So it's just going to be plus 3 to the power of x times 3 to the power of negative 1. And the rest of the equation remains the same. Now that that's out the way, that opens up the door to factorize. So now if I analyze the left-hand side, I can see a common factor amongst those two terms, which is 3 to the power of x. So I'm going to take it out to the front, open up a bracket, and if I analyze this term here, I took this one out, so this is the only one left over. And I'm going to do the same thing for this term. I took this out, so I've just got plus 3 to the negative 1 left over there. And then the equals 10 over 9 does not change at all. And after that, we're going to let Uncle Calculator do a little bit of heavy lifting for us here. So we're going to look at this bracket and just pump it in the calculator. So we just slot it in there and we get 10 over 3. So we replace that with a 10 over 3. Nothing else will change about the equation. And now the mission is to get this power on its own. So I want to get rid of this 10 over 3 by dividing both sides of the equation by 10 over 3 so that they can cancel on the left hand side over there. And then this side we're going to let Uncle Calculator do a bit of heavy lifting there for us. And when you pop that in your calculator, just make sure you've got like two separate fractions with the divide symbol in the middle, and you'll see that gives us 1 over 3. Okay, so if we have a look at this over here, this 3 over here, if it does not have an exponent, we assume it has an exponent of 1. And then we're going to yoink that up to the top so that it converts into 3 to the power of minus 1. Now the whole reason why I wanted to do that is so that I get the same base on both sides of the equation. And when I have the same base, I can grab the exponents, make them equal to one another, and then my job's done. I've solved for x. But I like to check myself, so let's grab our calculator quick. So you just grab your calculator, type in the original left-hand side, but instead of x's, you leave open brackets like that, and then you put your answer inside of those open brackets. So if I put minus 1 here, and I put it in this other little bracket here, press equals. Check what it gives me, but yes, it's 10 over 9. Yes, but. And your 4 marks come from the factorization, the simplification, same bases, and answers. Next up, we have our simultaneous equations, where there are 2 equations as well as 2 distinct variables. And we always start off with the simpler equation, which is this one, and I want to get x or y on its own. And in this case, it really doesn't matter which one you get on its own, because neither of them have a number in front, or their number in front is 1, if you want to see it that way. But I think I'm going to take the x over, And when I do that, it becomes the opposite sign, and I will be left with y equals 2 minus x. Now that we have y on its own, we're going to sub it into the other equation. And now we're going to grab this equation, and we're going to sub it into y's place in the other equation. So we just replace y with 2 minus x, and the rest of that equation will remain the same. Now we start to work on solving for x. So 2 plus 1 will give me 3, and then I still have that minus x next to the 3, and that's going to be equal to, and then nothing will change over here. And now I don't like fractions in maths, so I've got to have good coping mechanisms with fractions. So what I want to do is put this left hand side over 1, so that it sets me up for cross multiplication. Now if I have a 1 at the bottom, I don't really need to cross multiply it, so that's why I'm not cross multiplying that 1 up there, because nothing will change. But I'm going to cross multiply this x minus 1 up there, and it will successfully get rid of the fraction like this. Just make sure to keep everything in brackets when you cross multiply. And now that we've cross multiplied, I see a binomial times a binomial over here, and the magic word to get rid of those brackets is FOIL. So we're going to FOIL these brackets out, and if we go ahead and do that quickly, the first terms will give us 3x, the outer terms will give us minus 3, inner terms minus x squared, and the last two terms will give us plus x. And the equals 3, negative 3, nothing will change to that. And now, you might notice that we have a quadratic equation. So, same stock standard procedure, standard form, factorize, that whole spiel. So to get standard form, I'm going to grab that negative 3 and move it over to the other side of the equation. At the same time, I want to make sure I've got the right order going on. So I want the x squared first. Remember to bring its sign with it. Then in the middle, I've got 3x plus x, which will just give me 4x. And then I've got this minus 3 over here. And if I take this minus 3 over to that side, it becomes plus 3. And then it's all equal to 0 if I brought everything over. And because these 3's have opposite signs, they cancel with one another. And now this negative is bothering us, so we're going to get rid of it by dividing both terms, or all three terms in this case, by negative 1. And if we divide everything by negative 1, what happens is just the sign change. So this negative x squared became positive x squared, and this plus 4x became minus 4x, and 0 divided by anything is just 0. And now that I have standard form, I can notice the highest common factor between these two terms. There's an x in both of them. So I'm going to open up a bracket, and if I look at this first term, I removed one of the x's, so I've got another x left over. Another good way to see it is x times x is x squared. And then from the second term, I removed this x over here, so there's only a minus 4 left over once I remove the x. And then that's still equal to 0. And now we apply the zero factor theorem, so we look at factor 1 as well as factor 2, and we make each separate one equal 0, and with the word OR in between them. And then to solve for x, I'm just going to take this negative 4 over, it becomes positive 4. So here are my two answers for x. X equals 0 and x equals 4. Just remember we need to solve for y as well. So we've got to put these x values back into this x over here to get y. So I'm going to put the first x in of 0, and it just gives me 2 minus 0. And then I keep the word OR there. And then I put the second x value in, which is 4. So I'll put this 4 into x's place here, and that's how I get this 2 minus 4. And then I just work those out. 2 minus 0 is 2, or 2 minus 4 is negative 2. And there's my two answers for y. So 17 years later, we have solved these simultaneous equations. And wrapping this question up, you get 1, 2, 3, 4, 5 marks for the relevant steps shown in the screen. In 1.3.2, it says hence or otherwise determine the value of this expression. So if they use the word hence, that means look at your previous answers to help you. So we're going to sub in one pair at a time. So let's go ahead and sub in the first pair. So I'm subbing in this pair here. So you see this x, I change it to a 4 there, and then you see this y, I change it to a negative 2 there, and then we're going to slap that in our calculator quick. Okay, so we just go ahead, type that in, and we get minus a quarter. So there's our first value of the expression. Now if we try the other pair of answers, the x equals 0 and the y equals 2, something funny is going to happen. So if I put them in there, I'm going to get 1 over 0. And that 1 over 0 is undefined. If 0 is at the bottom, it's undefined. So that one's undefined. So we don't even explore that option. We even just leave it out. And our 2 marks here will come from selecting the right values to pop in as well as the answer. Coming up next, we have the nature of roots for 6 marks. So we've been given an equation and we need to find the values of m for which it has real roots. So if I want real roots, I'm going to gun for the following equation. Now I want b squared minus 4ac to be greater than 0 because b squared minus 4ac sits underneath the square root inside the quadratic formula. And if I square root something that's positive, that's going to give me real numbers. So we're going to start off by grabbing the equation they gave us. And we firstly got to see, is it in standard form? And it actually is. The x squared is first, the x is in the middle, and everything that does not have an x is at the end. So luckily that it's in standard form, we can extract a, b, as well as c, that we are going to sub into this formula here. And just some bonus information, this is called the discriminant formula. This triangle is a capital delta that represents the discriminant. So I like to set up my skeleton brackets, and then I'm going to pop b in b's place. I'm going to put a in a's place, and I'm going to put c in c's place. Now I'm going to go on a long mission to simplify this. And yo, to simplify this, good lord, Shaquanda. Okay, so I can see 2 things we need to do. We need to distribute this minus n over there, and this minus 4, I'll multiply it by that 2m just to start simplifying over there. So over here, minus times m will give us minus m, minus 1 times minus 2 gives us that plus 2, and minus 4 times 2m gives me this minus 8m over here, and everything else remains the same. And just a small thing, these square brackets can turn into circular brackets now, because there's no other brackets inside of them. And now to simplify further, that square over there is telling me to write the bracket twice. And this minus 8m, I can distribute that inside the brackets over there. Okay, so let's get that bracket there twice, and then minus 8m times m is minus 8m squared, and minus 8m times 1 is minus 8m, and the greater than or equal to 0 stays the same. Okay, now what's the magic word to get rid of these 2 brackets? It's FOIL, my brother. We're going to FOIL these brackets out, but... So if I multiply the first, it gives me m squared. Okay, I'm going to do the outers and inners at the same time. I'm going to get minus 2m, which will simplify to this minus 4m after I do like terms. And then plus 2 times plus 2 gives me positive 4. The rest of the inequality remains the same. And to know what to do next, we've got to assess what we have. So at the moment, we have a quadratic inequality. So we're going to solve the quadratic inequality. So we want to get standard form. Okay, so for standard form, we want the right order present. So we're going to do the m squareds first. M squared minus 8m squared. It's like saying 1m squared minus 8m squared. 1 minus 8 will give me negative 7, and then I'll glue the m squared on them. Minus 4m minus 8m give me this minus 12m in the middle, and then I've just got that plus 4 left over. The inequality and the 0 remain unchanged. Now this negative here is a problem. To get rid of that negative, we simply just divide every term by negative 1. And then when we do that, we're going to get a sign change. So negative, negative, positive will turn into positive, positive, negative. And we're going to see something interesting happening with our inequality. If I divide by a negative, the inequality will point in the opposite direction. Don't forget that small rule with inequalities. Now we're going to play a game called Factorize the Trinomial. So I'll start off with the factors of 7 underneath each other here. 7 is a prime number, so it only has 2 factors, 7 and 1. And then I'll start with the factors of 4 over here and here. So let's try 1 and 4. I'll multiply going across, so 1 times 1 is 1, and 7 times 4 is 28. Now the goal is we need to add or subtract these numbers to get the number that's in front of x, that positive 12. I cannot do that with 1 and 28, so I've got to start again. So what I do now is I switch the order of these two factors, put the 4 on top and the 1 at the bottom, multiply going across, and 1 times 4 is 4, 7 times 1 is 7. And can I add or subtract those to get 12? Bloody close. If I add them together, I get 11, but not quite 12. So we've got to try different factors of 4. Maybe a crispy little 2 and 2 there, but okay. 1 times 2 is 2. 7 times 2 is 14. Hey, how's it? We can add or subtract those to get 12. If I say plus 14 and minus 2, then it will give me plus 12. And last thing left to do is to bring this sign over and to bring this sign over, and then we just slap a little m over here, and we also put a little m over here, and now we can get our two brackets. The first bracket will be 7m minus 2, and our second bracket will be m plus 2. And then the inequality and the 0 at the end do not change. And from our factorized trinomial, we're going to need to get our CVs. So to get our CVs, we grab factor 1 and factor 2, and we make each factor equal 0 separately with a word or in between them. Now we just solve for m. So we're going to take that positive 2 over, we're also going to take that negative 2 over, and we are left with 7m equals 2 or m equals negative 2. Over here, to get rid of that 7, we divide both sides by 7 and we've arrived at our critical values. Next up, we need to draw a basic parabola to help us get our answer. So we're going to draw that here, and remember your lower critical value goes on the left, the higher one on the right. And then we need to recognize where the positive and the negative x values are situated on this parabola. So we're going to come back to this line over here, and they're basically asking us, where do you have negative y values? So I have negative y values starting from here and ending over there. And how I represent that is like this. When m is smaller than 2 over 7, but at the same time bigger than negative 2. And another notation is acceptable. You can say that m is an element that starts in negative 2 and ends at 2 over 7, and then I have to use the square brackets because I've got the inclusive inequality. And wrapping up this question, let's have a look where the 6 million marks are allocated here. Our first mark comes from substitution. The second mark comes from the condition of making delta bigger than 0. Third mark comes from simplification. Fifth, standard form. And then, this is the fifth mark. That comes from your factors over there. And the last mark comes from the answer. Okay, buckle up. This question is rougher than a goat's knee, my bro. Alright, so we want two real roots that are opposite in sign if m is less than 0. So if m is less than 0, we're going to grab the equation and analyze it if that's the case. So if m is 0, then, well, if m is less than 0, that's a fancy way of saying m is negative. So 2m will also be negative. 2 times a negative number also gives you a negative number. And if this number in front of x squared is negative, it's going to adopt a sad face. So we know one thing for sure, we're going to get a sad face parabola. And now we can have two cases with the sad face parabola. We can get the case where we have a positive y-intercept, and in that way, if I model it that way, this root will be negative and this root will be positive. Or I can get the case where the y-intercept is negative, and then I get a positive root and another positive root. So these roots have the same sign. They're both positives. These roots have opposite signs. This one is a negative root and this one is a positive root. They ask for the ones or the roots that are opposite in sign, so it's going to have to be this one over here. So long story short, we want a positive y-intercept. Now the y-intercept is located here where there are no x's. So it's going to be the m plus 1 for us. And we want to make that guy positive. And how we make something positive is we simply just grab it and make it bigger than 0. Anything bigger than 0 is positive. Now, we are going to grab this negative 1, the positive 1, and send it over. And it will just turn into a negative 1. Now we are not quite done. Remember earlier they said m is smaller than 0. So we've got to combine this and this into one inequality. So let me show you how we do that. So m needs to be smaller than 0. Kind of what I do is kind of ignore this side and just look at that side. You can see it reads the same thing. But now you see here the crocodile is eating m. So it's also got to eat m here. So if I get rid of this one, you can see it's kind of the same thing but backwards. The crocodile's still eating the same person. So now we've successfully combined them into one inequality, and that's our final answer. And wrapping this question up, your 2 marks come from the condition for C as well as your final answer. Question 2 starts testing us on our exponents. Do we know how to apply our exponent laws? And we need to do all this without the use of a calculator. So first things first, I want to prime factorize these big numbers. And my first instinct is to do that because there's no addition or subtraction here. It's only multiplication and division. So when we prime factorize, everything else will remain the same. Now I can kind of work this out manually without a calculator, but it's much easier to do it with a calculator quick and you won't lose marks. So to prime factorize with a calculator, you're going to press 512 and then the equals button. And then you press shift and then you see fact over there. So you press this button and it changes it to 2 to the power of 9. So we can successfully make that change there. And likewise, we can do it with the 64 as well to give us 2 to the power of 6. And then change that 64 to 2 to the power of 6. Now I can work those out manually, but it's going to take time. Like I want to save as much time as possible. And now we're going to apply law 2 of exponents, where if we're dividing the same base, we can subtract the exponents. Okay, so let's go ahead and do that with the 2's. So 9 minus 6 will give me that 3 over there. And then if we go ahead and do it with the x's, it's going to give me x to the power of 6, because 3 minus minus 3 gives me 6. A minus and a minus turn into a positive. Next up, these brackets are starting to bug me, so we need to get rid of them. And how we get rid of them is we shower the power. We grab the power, multiply it into those exponents, and let's see what we get after that. Okay, so 3 times negative a third gives me minus 1. You use your calculator to triple check yourself. It is worth your time. So that's just going to give me 2 to the power of minus 1. Now bear in mind your base does not change. You're only multiplying the 2 exponents. You don't touch the base. Okay, and then minus a third times 6 will give me this minus 2 over here. And then just triple check yourself as you go. 6 times minus a third is negative 2. And just in case you're curious, this is how to do it without a calculator. You start off by putting that 6 over 1, and then you see what's the biggest number that can fit into the top and the bottom. I think 3 can fit into the top and the bottom, so we divide both of them by 3. If I divide 3 by 3, I get 1. If I divide 6 by 3, I get 2. And then I say the top times the top to get my new top over here. And I do the bottom times the bottom to get my new bottom over here. And anything divided by 1 is just itself. So we can get rid of that over 1 and we get minus 2. So you can see why I like to use a calculator. It does quite a complicated thing quite fast. And now all that's left to do is use exponent law 3 to simplify this a little bit further. It's not really good practice to leave your answer with negative exponents like this. So instead we want to leave our answer with positive exponents. So how we cope with that is we put this over 1 and then we grab each respective power and move it to the other side of the divide line. And when I do that, the exponent gets the opposite sign. So if I move everything from the top, there's a 1 left over. And then if I move this 2 to the bottom, it becomes 2 to the power of 1, which is the same thing as 2. And then if I move this x to the bottom, it becomes x to the power of 2. And you can see how it went from negative 2 to positive 2. And there's our final answer. And wrapping this question up with your 3 marks. The prime bases, the 2 to the power of 9, 2 to the power of 6 get a mark. The simplification into that gets your 2nd mark, and the 3rd mark comes from the final answer, Machana Bean. Next up, we're going to be tackling a very challenging simplification question. So there's not a lot I can do currently at the moment. All I can really do is split up these 3 guys using law 1 of exponents, but the reverse version of it. So if I do that, it's going to look like this. And now I want to factorize and cancel to try to simplify. So there's 2 methods of factorization you can implement. You can do the common factor or grouping. The common factor is a longer way around, so I'm going to show you the grouping method. So in order to group, I'm going to need to rearrange a couple of terms. So the 2 terms that we're going to grab and move are these 2 terms. And if you're wondering why it's those 2 terms, I'm going to show you in a later step why I moved those ones. It's a bit hard to see at the moment. So if I do that, it's just going to look like this. And now, from the first 2 terms, I'm going to remove a HCF of x to the power of n, and I'm going to do the same thing with the last 2 terms. I'm going to remove a highest common factor of x to the power of n. And once that's done, I've got an x squared left over there. I took the whole thing out here as a common factor, so I've got a 1 left over. Took x to the power of n out, so I've only got an x left over there. Took this out, so I've got an x to the minus 1 left over there. Now you can see this bracket looks like the bottom, and that's why I moved this one next to that one, so that I get x squared minus 1 inside this bracket, hopefully group it later and cancel it with the bottom. For now, we're going to have to redirect our focus on this bracket here. We need to sort out this bracket here. And to start off that process, we're going to change this x to the negative 1 to 1 over x using our negative exponent law 3. Now, inside this bracket, I'm going to work on getting an LCD. And to start that process, I change this x to x over 1. And it looks like the LCD is x, so this fraction over here, I need to multiply the top and bottom by x to get that LCD. So at the top, x times x is just x squared, and 1 times x is just x at the bottom. And we can now finally morph them into one fraction, and it changes into x squared minus 1 over x. And we are finally starting to get somewhere. I just want to put in the last step so you can kind of see the logical steps here. And now we are making progress. Our brackets are almost looking the same. You see how we've got x squared minus 1 here, x squared minus 1 at the top there. So we need to do something about this x at the bottom, and I'm going to show you. It's quite complicated. So you firstly move that x out into the common factor over there. And then over here, we're going to use an exponent law. I am dividing the like bases. So I'm going to subtract the exponents. And after I subtract the exponents, it turns into x to the power of n minus 1. Now our brackets are the same, we can remove it as a common factor. So the HCF is that bracket, as previously mentioned. So we write it first, and we open up a new bracket. Now what's left over from the first term is this x to the power of n, so that goes in first. And then I have a plus, and I took this bracket out, so I have an x to the power of n minus 1 left over. And the bottom does not change at all, it's still over x squared minus 1. And lastly, these 2 brackets cancel, and I'm just left with the contents of this bracket, and we are done. Wrapping things up with your 3 marks, simplification, factorization, and your answer get you those 3 marks. Very slag question in my opinion. We have officially reached the surds in our paper, and to start simplifying this surd expression, we need to use surd law 1. Which states if I'm multiplying 2 separate square roots, I can combine them into one big square root and multiply the contents of what used to be in both of them. Just remember brackets when you do this step. So if we apply this law to our example, we do a big square root, and then I like to leave like 2 empty brackets, and I fill in the 2 separate brackets with what was under each separate square root. And now I need to get rid of those brackets. And to get rid of those brackets, the magic word is FOIL. We're going to FOIL those brackets out, my chana beans. And let's start off with that process. So we're going to keep a long square root there. The first two terms, a times a, will just give me that a squared over there. Then I've got a positive times a negative, so I'm going to get a negative over here. And then I kind of just glue a to the front of the root like this. And then we're going to get the same thing present with the inner two terms. I'm going to glue this a to the front of that root. And I have a positive times a positive. So I will get a positive term over here. And like we said, we're going to glue a to that root. Now, if you recognize the dots, you could have saved yourself a bit of time. These two terms are going to cancel in the next step. Okay, and then lastly, we're going to get that root times the root. And it is going to be a minus because I've got a positive times a negative. And now we're going to work on simplifying this. So to start simplifying here, we're going to keep the square root. That a squared is going to stay behind. And then these two terms cancel, as we discussed earlier. And then over here, I'm going to have a minus, because I just keep that minus there. And then can you see that these are exactly the same? So another way of writing that is basically you can take that entity and you can square it. And then this square cancels with the square root, and we're just left with that 2a minus 1 in a bracket. And then next thing is next, we need to distribute this negative in. So let's grab it and distribute it quick. We're just going to get a sign change happening there. So minus 2a plus 1. Now we're going to work on factorizing this trinomial to hopefully cancel out the square root. And I'm just going to move the trinomial here to start off that process. To start off that process, I need to look at the factors of 1. So 1 is a prime number, I suppose. No, it's not a prime number. 2 is the first prime number. Sorry, I'm digressing here. Okay, 1 times 1 is 1. Okay, we need to add or subtract those to get negative 2. And to get that negative 2, I'm going to have to say minus 1, minus 1. So my two brackets will be a minus 1 as well as a minus 1. And another way to write that is a minus 1 squared. So we can go ahead and change it to that, keeping the square root over it. And the square root and the square cancel with one another, leaving us with a final answer of a minus 1. And let's have a look where the 4 marks come from. Your first mark comes from the single surd, second mark comes from the quadratic expression, third mark correct factors, and your last mark is the correct answer. Okay, welcome to your challenge round with surds. Now it's quite difficult to see what to do with this question, so I'm going to show you how to cope with it. So what we're going to need to do is divide both sides by this 1 minus root 2, so that it takes us to this. These are going to cancel, and we're just going to be left with x plus y root z equals this massive expression. Now the reason I wanted to do this is so I could rationalize the denominator. It takes me to a space where I'm familiar. And to start off that process, I'm going to wrap the top here in brackets, wrap the bottom in brackets. And then I look at the bottom and I multiply it by that, but with the opposite sign, the conjugate. And whatever I multiply the bottom by, I've got to multiply the top by that very same thing. So in summary, we wanted to divide by that so that we could go back to a place we're familiar and rationalize the denominator. Okay, now we're going to start rationalizing the denominator. And to get rid of these brackets, your magic word is FOIL. So we're going to FOIL the top and FOIL the bottom separately. Okay, so let's speed run this foiling quickly. Minus 3 times 1 gives me this minus 3 over here. Minus 3 times root 2 gives me minus 3 root 2. Root 2 times 1 just gives me plus root 2. And then root 2 times root 2 is the square root of 4, which is just 2. So I'm going to get a plus 2 at the end here. 1 times 1 will just give me this 1 over here. And then 1 times root 2 is just plus root 2. And then minus root 2 times 1 is minus root 2. If you recognize the dots there, would have made your life a bit easier. And then a minus times a positive is a negative, and root 2 times root 2 is just positive 2. Now that we foiled out our brackets, we're going to collect like terms. So at the top, I see two like terms, that positive 2 and this negative 3. So minus 3 plus 2 will give me this minus 1 over here. And then I see a couple more like terms on the top. Both of these have like kind of a base of root 2. So minus 3 root 2 plus 1 root 2 will give me this minus 2 root 2. And then at the bottom, as we discussed in the previous step, these two guys are going to cancel. And then I've got like terms with that 1 and minus 2. 1 minus 2 will give me negative 1. So now that we are left with this, it is quite straightforward to simplify. I'm going to split it up. So I'll put the first term on top over the bottom. And then I'm going to put the second term on top over the bottom here. And then a minus divided by a minus will give me a positive. So I get positive 1 over there. And then a minus divided by a minus will give me another positive. And I get plus 2 root 2. Because anything divided by 1, it doesn't change it. And now that the structure of this is matching the structure of that, we can simply read off the values of x, y, and z. And we're going to do it just like this. So if we have a look over here, we can see that x is 1. Okay, and then if we have a look at the y's, we can see that y is 2. It's the number in front of the surd. So we can just state that y is 2. And then z is the number inside of the surd, so we can simply read off that z is 2. And then we're going to have a look where the 4 marks come from. Your first mark comes from isolating those variables. Second mark comes from the simplification after foiling. Third mark comes from the simplification into this. And your last mark comes from all 3 final answers. Starting off question 3, we have a trig pattern. And we are asked to explain how each term is found from the previous term. And in order to do that, we need to look at this tan x and use our trig identities. So tan is equivalent to sine theta over cos theta. So in our case, it will just be sine x over cos x, and the rest of the pattern will remain the same. Now we can actually see what's happening with the pattern. Every time I move across, I'm multiplying by cos x. So if we had to explain how we found a new term with the previous term, we just multiply the previous term by cos x to get the new term. And to wrap this question up, we need to write down the 4th term of the pattern. So to do that, we come back to our pattern. We're just going to multiply by cos x yet again, and we get sin x cos squared x. And your 2 marks in this question come from each answer to each question. In question 3.2, we need to assess what type of pattern we have so that we can get the nth term for this pattern. So let's have a look what's going on with this pattern. So we can see I add 3 to get from minus 1 to 2. Add 3 again. Add 3 again. So it's got a constant first difference, which tells us that this is a linear pattern. And there's 2 methods we can use to get the nth term. I'm going to go through both of them. So in method 1, we start off with a generic formula, dn plus c. Now, to get the c value, you have to take term 1 minus the difference of 3. So we're going to fill those in quickly. So term 1 is just negative 1, and the difference is 3. Minus 1 minus 3 will give me this minus 4 over here. And now we can pop it into c's place. And this d over here, we replace it with our constant first difference of 3. So let's go ahead and make those changes. And then there's my nth term. It's 3n minus 4. You can see the c's came from these orange guys here, and the d's came from the green guys over here. And method 2 is more using a metric formula. So this you get introduced to in metric, but you are still allowed to use it in grade 11. Bear in mind these ticks and crosses that show you when it's on or off the formula sheet. That is for a metric formula sheet. Okay, so A is a placeholder for the first term. The first term is negative 1, so let's pop it in quickly. Now, when you're getting the nth term, you leave this n here, so do not touch this n. And then the constant first difference, we have that to be 3. So we're going to change this d to a 3, which I like to keep in brackets, so that it helps remind me I've got to distribute. And we're going to do exactly that. We're going to distribute that 3 inside of there, the minus 1 chills, and I get plus 3n minus 3. Then I've got like terms here, minus 1 minus 3 gives us minus 4, my China bean. So we circle back to the same place and we get the same answer. So this one is a very good one to get used to. It's going to help you out in matric. I would recommend going down method 2's path and having a look where your 4 marks come from. If you had the answer only, you would get 4 marks. And then for this method, the value of D3 will get you a mark. Substitution into this formula will get you a mark. The value of C to be minus 4 gets you a mark, as well as the answer gets you the 4th mark. And now we need to find out which term of the pattern will be equal to 161. So using our rule that we got from the previous question, we've got to remember that Tn is a placeholder for the term value. And this 161 is a term value because the term is equal to it. So I'm just going to replace this with 161. And after we make that change, it's just like solve for x. So to isolate n, we've got to take this negative 4 over to the other side of the equal sign. It's going to become plus 4. 161 plus 4 is 165. This 3n doesn't change, so he stays the same. Now I need to get rid of this 3 to get n on its own. And to do that, I'm going to divide both sides by 3. And then they cancel over there. And 165 divided by 3. Let's ask Uncle to step in here, brother. Alright, how's it put? 165 divided by 3, 55. Okay, thank you, brother. So now we know that n is 55. And your 2 marks are awarded over here for your substitution of 161 in the right place, as well as your final answer of 55. We have officially hit the quadratic sequences in our papers, and in maths we cannot work with pictures, we have to work with numbers. So I'm going to convert these pictures into numbers, and let's see what they're asking for, the total number of squares. Okay, so I'm going to count the squares in figure 1. I see 1 square, so there is 1 square in figure 1. In figure 2, I'll count 1, 2, 3, 4 squares. So in figure 2, there are 4 squares. And in figure 3, I count 9 squares. So there are 9 squares in figure 3. And how to get this number, you basically just take your figure number and you square it. So 1 squared will give you 1. 2 squared will give us 4. 3 squared will give us 9. So if I want to find out how much is in figure 5, I take figure 5, square the 5, and I get 25. So there are 25 squares in total for term 5. And that's where your 1 mark is awarded for this question. In the next question, we've asked how many dots there will be in figure 7. So let's count up the dots quickly. In figure 1, I count 4 dots. So there are 4 dots in figure 1. In figure 2, I count 9 dots. So there are 9 dots in figure 2. And in figure 3, goodness gracious, quite a few dots here. I count 16 dots. Okay, now I'm noticing something. 3 squared is 9, but if I say 4 squared, it's 16. Now the same thing is happening here. If I just add 1 to this, so 2 plus 1 is 3, and I square that, I'm going to get this. So if we jerry on to the rule, we just need to add 1 to our input value, wrap some brackets around it, and then square it to get this 4. And that's going to work with all of them. So I'll just add 1 to my input value, square it. So we're going to do this with the 7 over here. We're going to grab that 7 and put it in our rule, and 7 plus 1 is 8. 8 squared is 64. So we get 64 dots at the end of the day, with our singular mark being awarded over there. Next up, we need to show that an expression for the number of dots can be written as n plus 1 squared, as we did kind of see in the last question. So to do this, we're going to need to grab our pattern. Remember, we're working with the number of dots. So we go to that number of dots pattern we had in the previous question. And to cope with quadratic sequences, you need to know 4 formulas off by heart. And these are those formulas. So at the bottom here, you have 2a equals something. We're going to go get that now. 3a plus b equals the middle one, and a plus b plus c equals the top one. You use this one to get a, you use this one to get b, and you use this one to get c, and then finally you put them in here. So after this whole process, we should get this. So let's start off the process. To get from 4 to 9, I've got to add 5. And then to get from 9 to 16, I've got to add 7. And then to get from 5 to 7, I've got to add 2. And now that we have all those filled in, we're going to start with this equation here. Divide both sides by 2. And we get a to be 1. And then we're going to come to this formula, 3a plus b equals 5. And we're going to fill our a value in. Remember, we got a to be 1 to get this equation over here. And then 3 times 1 is just 3. Move that over, it becomes minus 3. So we get b to be 2. And then we come to this equation over here. We're going to fill a and b in. A is 1, b is 2. Let's go ahead, fill those in. 1 plus 2 is 3. Take that 3 over, it becomes minus 3. And 4 minus 3 is 1. So we get c to be 1. Now we can replace a, b, and c with their corresponding values. So a is 1, so we can just put that in, but we don't even need to put it in, because 1n squared is the same thing as n squared. B is 2, so we can replace that b with a 2. And c is 1. Let's go ahead and replace it. So we've got a plus 1. Now we're going to start to factorize. So if I look at the factors of 1, thankfully there's only 2 factors, or should I say 1 factor, 1 times 1. And we need to use those factors to get this plus 2 in the middle. So to get that plus 2 in the middle, I'm going to have to say plus 1, which will give me 2 brackets of n plus 1 and n plus 1, which we can write as n plus 1 squared. And now we've officially finished the question. We've proved that the nth figure can be written as n plus 1 squared. And our 4 marks over here come from our a, b, and c value, as well as the correct second difference of 2. In 4.2, we've got athletes running along a straight road, and we've got a distance from a fixed point given with this expression, and the distances are recorded in the table below, and I need to get the values of r and s. So this is a quadratic pattern. And we know that due to the structure of its general term, as we've seen in previous questions. So we need to start working on basically getting our upside down pyramid, or seeing what we do to get to the next term. So to get from 17 to 10, our minus 7. And then carrying on that trend, our minus 5 to get from 10 to 5, and then our minus 3. And now we can see a beautiful constant second difference emerging. I add 2 to get from minus 7 to minus 5. And once again, I add 2 to get from minus 5 to minus 3. So there's our constant second difference. So we're going to use that to get r and s. So we've got to start at the bottom. So with that minus 3, I add 2, and I get minus 1. So to go from here to here, I need 2 minus 1. So 2 minus 1 will give me 1 as r. Then we start at the bottom. We're going to add 2 minus 1 plus 2 gives me positive 1. And then 1 plus 1 will give me the value of s to be 2. So now I can conclude that s has a value of 2 and r has a value of 1, and you just get 1 mark a pop for each of those answers. Next up, we need to determine the values of a, b, and c, which are situated in our general equation over here. So we're going to need to get the general equation and read them off. And to get the general equation, I'm going to remind you of those 3 formulas from earlier. First one is 2a equals the bottom number. Your second one is 3a plus b equals the middle one. And the third one is a plus b plus c equals my first term. So we're going to start off down here. 2a equals 2. Divide both sides by 2 and we get a to be 1. Now we're going to grab this equation. And I'm going to fill in the a value of 1 into that equation. So it just changes a to a 1. And now we're going to solve. 3 times 1 is just 3. Take that over, it becomes minus 3. Minus 7 minus 3 will give us b to be negative 10. Now we're going to grab our last equation. A plus b plus c equals 17. We're going to fill in a and b. A is a crispy little 1. B is that minus 10 over there. Let's fill them in. Okay, and then a plus and a minus will give me a minus. 1 minus 10 is minus 9. Take that minus 9 over. It becomes plus 9. 17 plus 9 will give you 26 for C. And then the last thing left to do is to fill those back into here. We don't really have to because we just asked for the values of A, B, and C. But trust me, you're going to want to get into this habit. So A is just 1. We're just going to fill that in. And we don't even need to write it. And then B is minus 10. So we fill that in as minus 10n. And C is 26. So we just slap on a plus 26 there. And then we've got a winner chicken dinner on our hands here, but. And wrapping this question up, your 4 marks, the second difference of 2 gets you your first mark, and then the value of A, B, and C get you your second, third, and fourth mark. Next, we are asked how far is the athlete from P when n has a value of 8. So using our general formula from the previous question, they're asking us how far. So they're asking for the distance. So they're asking for dn. So what I do is I keep the structure of this exactly the same, and I'm going to change all these n's to the specified value of n equals 8. So we go ahead, pop those in there, and then we're going to ask Uncle Calculator for a bit of assistance there, brother. So we just tune him, how's it? Can you help us there, Uncle? Oh, thank you, man. 10 meters, boss. So the distance will be 10 meters when n equals 8. And your 2 marks are awarded from the substitution step as well as the final answer step. Next up, we have a couple of friends having an argument, Michaela and Jack. So one of them claims there's a minimum value. The other one claims it does not have a minimum value. And we need to answer who is correct and back ourselves up with the appropriate calculation. So let's have a look at our general equation for this quadratic pattern. Now, if we think back to our standard form of a parabola, it's the same thing as like the standard form of a quadratic pattern. Check this, ax squared bx plus c. This one is an squared plus bn plus c. So you're just switching out the x's for n's. Now if we look at the number in front of n squared, it's a sneaky little weasel, it's a 1. So it's positive, so it's a happy face. And now I want to get to know it a little bit better, so I want to find out what the turning point of this is. And for that, I'm going to use the turning point formula. So we're just going to pop a and b into that formula. B is the number in front of n, so it's at minus 10. And then a is the number in front of n squared, which is a sneaky weasel, a 1 over there. And then if I literally pop that into my calculator, it tells me n equals 5. So if we had to draw a rough picture of what's going on here. So if we have Tn in y's place, in this case it's actually dn, and then we have n in x's place, this 5 is telling me that at term 5, you're getting a minimum y value for this pattern. It's the smallest value of this pattern you're ever going to get. So Michaela is correct. So we just need to leap to the conclusion that concludes there is a minimum and Michaela is correct. And then our 3 marks come from the substitution into this formula, the answer for the turning point of our parabola, as well as concluding that Michaela is correct with the correct explanation to back that up. Starting off our financial maths, after 2 years, the phone is worth a third of its original value, and we need to use the reducing balance method to calculate the annual rate of depreciation, which is our interest rate over here. So we start off these questions by changing this P to an X so that the A amount is a third of that X value, and then we just pop the number of years into its respective place. Now to get rid of these X's, we simply just divide both sides of the equation by X, all the x's cancel out, and we are left with a third equals 1 minus r squared. Now that square is a bit of a problem, so to get rid of it, we square root both sides of the equation, and then on the right hand side of the equation, this square and square root cancel out, and we just left with 1 minus r. Then over here, we're going to pop that into our calculator, just press S to D, and then that 5 rounds a 3 up to a 4, and we're going to leave this to 4 decimal places, so that our final answer can be to 2 decimal places. Next up, we're going to take this 1 over to the other side of the equation, and it becomes minus 1. So we just use our calculator on the left hand side there. You can see how I get that minus 0.4226. And then on the right hand side, we are left with minus r. Don't forget to take that minus with the r. And then we divide both sides by a negative, so essentially these negatives just disappear like that. Now we times this decimal over here by 100, so let's times that by -1 to get rid of the negative, and then we times that by 100, and we get 42.26% as our final answer to this question. And your 2 marks simply come from your substitution in the beginning, as well as your final answer. In question 5.2, Carl is saving up some cash money for his car wash, and we need to calculate the effective interest rate. So you need to know this formula off by heart. This is not on the formula sheet. So let's have a look at our nominal rates. It needs to be a decimal, so the 7.5% over here. We grab it, divide it by 100, and it's going to be 0.075 when I pop it in this formula. Now the n, I'm going to choose the monthly option because it is being compounded monthly, and then we just pop all those goodies into the formula. So we replace our n's over here with a 12, and the 0.075 goes into the nominal interest rate. Now we're just going to put this in our calculator. So we pop it in, press equals, and we get 0.0776. This 3 will round that 6 down, so it stays the same. And then this answer that our calculator returned us, we times it by 100, and it gives us our effective rate to be 7.76%. And wrapping this question up, your 3 marks are awarded for the substitution, simplification, and answer. In question 5.2.2, we learn a bit more about Carl's investments. So we're going to have to set up a timeline and transpose all this information. So let's go ahead and do that. Firstly, we're going to be using the compound interest formula. And then I'm going to show you how to construct this timeline. So Carl deposits 10,000 Rand right at the beginning. And then at the end of the first year, the interest rate changes. So for the first year, I've got an interest rate of that 7.5%. And then for the remaining 2 years, I have an interest rate of 7.8% compounded quarterly. And I know my timeline is spanning for 3 years because they set it over here. And then 6 months later, Carl deposits a further 5,000 Rand. So 6 months after that first year, he deposits another 5,000 Rand that sits for a year and a half till the end of the investment. And bear in mind that 10,000, we're going to have to do 2 separate calculations to get to the end of the timeline. You have to do that when the interest rates are changing. So let's go ahead and start doing that. So we're firstly going to start off with the 10,000 Rand. We're going to do them separately. So I'm going to put the 10,000 Rand into P's place for the compound interest formula. So let's go ahead, chuck it in. Okay, now over here, I'm going to put this bracket. So we're going to have the interest rate of 0.075. Don't forget to divide by 100. Divide that by 12 because it's being compounded monthly, and I'll raise it to the power of 12 because it's sitting for 12 months with this blue interest rate. Then I'm just going to add on the next bracket straight away for those 2 years. So for those 2 years, I've got this interest rate of 7.8%. Don't forget to divide by 100. I'm going to divide that by 4 because it's quarterly. That's spanning over 2 years. So I say 2 times 4, which gives me 8 quarters inside of 2 years. And then we are going to pop that in the calculator. Okay, so we just go ahead, pop that straight in, and it gives me 12,000 bucks and some change, my butt. And I'll keep that to a neat 2 decimal places. Now we're going to deal with the 5,000 Rand that sits for 1.5 years. Okay, so for the 5,000, that 5,000 sits with the orange interest rate. So we just chuck that in, divided by 4 because it's quarterly, and it's sitting for 1.5 years. So 1.5 times 4, and then just be careful when you type that in your calculator. So you need to use the mixed number button over here. So you press shift and the fraction button, and then it's 1.5 times 4 at the end there. And then we get a nice crispy little answer of just over 5 G's, my bro. And now all that's left to do is we're going to add these two together, and we're going to see if Carl has sufficient funds. He needs 17 grandaroonies to actually afford this new equipment. So we're just going to add these two amounts like this, pop that in the calculator, and it gives us, a little bit over 18 grand. So Carl will definitely have sufficient funds, and he's even going to have a nice little takeaway there, a little over a grand left over. And wrapping this question up, our 5 marks, 1 is awarded for the correct substitution there, multiplying by that bracket gets you the 2nd mark, substitution for the 5,000 gets you a 3rd, our answer gets our 4th, and our conclusion gets our 5th mark. In question 5.3, we have 2 friends, each invest in 6,000, Mervyn and Haley, and we need to see who's got the larger investment. So we need to make a comparison. So let's start off with Haley. So Haley will be using the compound interest formula because we can read that there. It's being compounded quarterly. So we're going to set that up as follows. She's investing 6,000. Don't forget to divide your interest rate by 100. It's being divided by 4 because it's quarterly. And then that's running for a total of 5 years. So I just say 5 times 4, which gives me 20 quarters. And then we're going to pop that in the calculator quickly. And our calculator just gives us something shy of 9,000 bucks over there. So now we know that Haley will be receiving just under 9,000 Rand for her investment. So now let's focus on Mervyn. So for Mervyn, we're going to be using simple interest. So let's grab the simple interest formula. And then let's pop in our goodies into the simple interest formula. 6,000 bucks, and then 1 plus. The investment rate for Mervyn was 8.5%, so don't forget to divide that by 100, and we're going to multiply that by 5 years. Pop that into our calculator, and we get 8,550 Rand. Now Mervyn also receives a bonus, so we've got to calculate that bonus and add it on to this. And the bonus is exactly 5% of the principal amount. The principal amount is 6,000. So we just say 6,000 times 5 over 100. Make sure that's a fraction. And pop that into our calculator. It returns us 300 bucks. Now let's add that 300 bucks onto our accumulated amount. And that will give us a sum total of 8,850 Rand. So at the end of the day, Haley still has a larger investment. And wrapping this question up, your 17 billion marks, 2 for substitution over there. Each respective A value gets a mark. The total for Mervyn gets you a 5th mark, and the conclusion gets you your last mark. In question 6, we start with exponential functions. Let's have a brief look at exponential functions. So with exponential functions, they look like ramps. So they can exist above the asymptote if A is positive, and below the asymptote if A is negative. And we've got one asymptote for exponential functions, which is located at the end here, and it is a horizontal asymptote that goes from side to side. Now with our particular equation, do you see how they're not adding anything at the end? So if they're not adding anything at the end, we assume like they're adding 0. So now we know where our asymptote is. And we can color code our graph accordingly. So we have an exponential function. So you can see here, check out the shape of this exponential function. It's adopting this shape here. So I already know my A value is going to be positive and my base is going to be smaller than 1 but bigger than 0 at the same time. So if we need to write down the domain of f, this graph goes on forever with the x values. It goes forever to the left and forever to the right, so it exists at all x values. And we can represent that in one of two ways. I can say x is an element of real numbers, or I can say x is an element that spans from negative infinity to positive infinity, always using circular brackets for infinities. And if I have to write down the equation of the asymptote of f, it's here. It's this y equals 0. It's this dashed line that goes across that is on top of the x-axis. And your 2 marks simply just come from the answers here. In 6.3, we are given the b value. It's 3/4. And with that, we need to calculate the value of a. So we're going to go ahead and replace this b with the value they supplied to us. And then to get missing stuff in my equation, I need to sub in a point. So I'm going to sub this point into this graph. And we do it just like this. F of x is a fancy placeholder for the y value. The y value is 144, so I pop that in there. And then this x, I simply just change it to this x value of 2. And now I can work out a. So I'm going to square this bracket quickly. And when you square it in your calculator, just make sure to wrap it in some brackets. And then you see you get that 9/16 that I've got over there. And now to get a on its own, we need to divide by the number in front of it. So we're going to divide both sides of the equation by this 9/16. And I must type it into my calculator like this. Just make sure you say 144 and then use the divide button and a fraction over here. Press equals. And then we get our a value to be 256. Now they're not actually asking you to get the a value. What they actually want you to do is take that a value, put it back in, and finalize your equation. And your 2 marks over here come from your substitution as well as your final answer for a. In 6.4, there's a new graph g that is obtained by reflecting f over the y-axis, and we need to write down the equation of g. So we're going to reflect the red graph over the y-axis, and we will get this green graph g. And we're briefly going to go through this transformation. So the transformation is the reflection over the y-axis. The notation is when your x changes to a negative x. So if you see the negative inside the bracket in front of x, and the rule is to change x to negative x. So that's exactly what we do to get its equation. We just change this x to a negative x, and then this g of x's equation. So we use the red graph because that's the one that's being reflected, and then it's as simple as that. Next up, we need to tell them if g is an increasing or decreasing function, and just remember g is your green graph. So going from left to right, you can see we're going uphill. If we're driving a car, we're going uphill. So it's definitely an increasing function, and if we had to give a reason, as your x value increases, your y value also increases. And your 1 mark in this question just comes from the correct equation for g of x, and your 2 marks in this question come from the word increasing as well as the correct explanation. In 6.6, we've got a bit of hieroglyphics over here. And yeah, we need to prove that this mess is equal to that mess. Okay, we're going to start with the left-hand side. So with the left-hand side, I'm going to keep the structure exactly the same. So this f of x, I'm going to replace it with f of x's equation inside the square bracket over here. And then you can see I'm still maintaining that square on the outside of the square brackets. Then I'll put that minus here. Now f of negative x, that's giving you instructions to replace this x with a negative x. So you can see I've done that inside over there. And now to simplify this, we're going to distribute those exponents in, aka shower the power. And we multiply exponents when we do that. So we're just going to get 256 to the power of 2. Because if it doesn't have an exponent, you assume it's 1. And then 2 times x will give me that 2x. And then 1 times 2 will give me this 2 over here. And 2 times negative x will give me this negative 2x over here. And that's as far as you can simplify. So now we're going to direct our attention towards the right hand side. And then when I start with the right hand side, I want to keep the structure exactly the same. Now you see this A over here, we got A earlier to be 256. If you remember back to question 6.3, you can see here A is 256. And that's why I changed these A's to these 256's. Now this f of 2x, it's giving you instructions to take this equation, replace this x with a 2x and put it inside of here. So we do that. You can see here, it's a 2x. And then for the next one, very similar, it's giving you instructions to replace this x with minus 2x. So we do exactly that. And then to simplify this mess over here, we are going to distribute the 256's inside. And when we do that, we add their exponents. So if I add their exponents, I just say 1 plus 1 to give me this 2 over here, and then this does not change at all. I'm just multiplying these factors over here. Likewise over here, I'm just going to multiply these two. This does not change at all. And I simply add the exponents there, and I get 256 squared, and then that fraction to the power of minus 2x. Now you can see this expression for the left-hand side is exactly the same as this expression for the right-hand side. So now we've officially proved that this mess is equal to this mess. And wrapping this question up, your 3 marks are awarded for the substitution in this line, the expression for the left-hand side, and the expression for the right-hand side. In question 7, we get introduced to our hyperbolas. Now, Kev, yes, my brother, how do you know this? It's because x is at the bottom of the fraction over here. And I can tell a lot about this function just by looking at it. So if I analyze the a value, that number on top, I can see it's positive, so it's going to be in these 2 quadrants. If I analyze this number at the end, that is going to be my horizontal asymptote that goes left and right. And if I analyze this at the bottom over here, that will be my vertical asymptote. Just remember, it must be the opposite sign if it's in standard form. And from that, the equations of the asymptotes, this equation here, y equals -1, and it's this one here, y equals -4. And you can see here, asymptotes, plural, it implies there's more than one. And your 2 marks come from each equation. So next up, I need to calculate the intercepts of the graph of f with the axes. So I'm going to grab this equation of f of x, and we're going to start working on the intercepts. Now to get intercepts, you make the other guy equal 0. So if I want the x-intercept, I make y equal 0. And if I want the y-intercept, I make x equal 0. Let's start off here with the x-intercept. F of x is a fancy placeholder for y, so I'm going to change f of x to a 0, just like this. You can see how this f of x replaced with Kanda Mababa. Next up, we're going to grab that -1 and move it over to the other side of the equation. And just remember, when you do that, it's going to turn into +1. And now we can start the process of cross multiplication. So I put 1 over 1, and then I grab the bottom, take it up and multiply. And then 1 times that bracket won't really change anything. So I'm just going to get x plus 4 on the left hand side, and it's equal to 2. It's equal to what's left over there. Or you can say 1 times 2 gives you this 2. And then we're going to yoink this +4 over. Bear in mind, it becomes -4. 2 minus 4 will give us -2. And after you have that -2, just make sure you write the full coordinate like this. -2 with the y value of 0. And then the y-intercept is a lot easier. We just make x equals 0. So we change this x in the equation to a 0. And then we just pop that in our calculator. How convenient. Okay, so we just pop that in, press equals, and it gives us -1/2. So always remember, write the full coordinate under that for the y-intercept. Over here you have an x value of 0, and whatever y value you calculate goes in this place for the y value. And your 3 marks in this question are earned from making y equals 0 over there, this x value and this y value. In question 7.3, we are asked to sketch the graph of f, clearly showing the asymptotes with the axes, the asymptotes and intercepts with the axes. So let's see what we know about this graph. We know a lot already. We know where all its intercepts are, all its asymptotes, as well as A is positive, so it's going to be in those two quadrants. So let's get a Cartesian plane going. We'll start off by getting our asymptotes in. So this asymptote will go at -1, it's going to go across like this. So it will look something like this over here. Now let's do the vertical asymptote. It's going to go up and down. It's going to be at -4, so quite a way out, like over there. So it will look something like this. Okay, let's get our x-intercept and y-intercept on here. Our x-intercept will be like halfway in between over there. And our y-intercept will be at -0.5, so it will be above this line over here. And then we can just sketch in our two curves. And now we've successfully done everything they've asked. We've marked off our asymptotes with these labels here, marked off our intercepts with these labels over here, and we've successfully drawn it with the right shape. And that's exactly where your 3 marks will come from in this question: shapes, intercepts, as well as asymptotes. In question 7.4, we are getting the image of the x-intercept if it's reflected about the axes of symmetry, which has this equation. So let's see where that is going to be. So I've represented the axes of symmetry with orange. So this orange line here is that axis of symmetry they're referring to. Now I'm going to take this x-intercept reflected over that line to find the image down here. And how we do that is with the following strategy. Whatever distance I go left to this asymptote, I do that same distance to go left there. So to go from -2 to -4, I'm going 2 units across over there. So I've got to go 2 units across over here, and I can get my x value to be -6, because I'm going from -2, and then I go back 2, back another 2, and then I get to -6. And there's a very similar process with the y value. If I go down 1 over here, I'm going to have to go down 1 over here to find my y value to be -2, because I start at 0, go down 1, go down another 1 to get to -2. So this coordinate they're asking for is -6 and -2. And you will simply just get 1 mark for your x value and 1 mark for your y value in this question. In question 7.5, we need to write down the range of y equals minus f of x. Now that minus in front of f of x is telling me there's a transformation at play over here. And if we have a look at the relevant transformation rule, when you have this notation, sort of a new function equals the old function with a negative being multiplied in front, that is a reflection over the x-axis. So we're going to take this graph and reflect it over the x-axis. And our new graph will look something like this. It's going to place our horizontal asymptote at +1, and that will definitely have an effect on range. So let's start structuring our answer now. So range tells me where the graph exists, and it deals with y values. So we're looking at our y values. So this graph exists at all y values except this y value here of 1. So how we state that in maths is we say y is an element of real numbers. That's saying y exists everywhere. We put a semicolon next to that. And then we state that y cannot equal -1. And in summary, what that says is y exists everywhere, but y doesn't exist at -1. At +1, sorry. It's an asymptote. The graph never ever touches that y value. And you just get 1 mark for the correct answer for this question. Slagbot. Next up, we have quite a difficult question. Describe the transformation of f to g if they give us the equation of g of x to be this. So what we need to do is look at our original equation, and then we grab this new equation and we ask ourselves, how did we get from the original one to this one? So you kind of have to work backwards here. So on top here I see -2, but on top here I see +2. I want them to kind of look the same. So I'm going to take that negative down to the bottom, and I get this. And then I distribute that negative inside the bracket to get this. And now I can read off my graph, compare the old one to the new one, and x change to negative x. And when x changes to negative x, that is the rule for reflection over the y-axis. So pretty complicated to see this one, quite a tough question. And your 1 mark just comes from reflection over the y-axis, the correct description for the transformation. In question 8, we've been given a parabola and a straight line. So what I'm going to do is fill in all the points. My parabola is going to be blue and my straight line will be green. And now we need to show that the equation of j can be written as what they gave us over here, this minus 2x squared plus 4x plus 6. So we need to get the equation of the parabola essentially. Now there are two equations I can utilize to do that. I can use my turning point equation or my x-intercept equation. I think I'm going to use the turning point equation because I have the turning point. I've got one x-intercept but not the other. So I'm not going to go for this one. And we're going to use the turning point form. And now we're going to fill in our turning point. So the x value of the turning point is 1. So I'm going to change this p to a 1. And then the q value, the y value of the turning point is 8. So I'm going to change this q to an 8. And then we need to get the a value. And to get the a value, I'm going to sub in a point that's on my graph. So I can choose any point except the turning point because we just put that in. So I'm going to choose this, the y-intercept, and I'm going to sub it into my function. So when I sub it in, I just replace y with the 6. And I replace x with the 0, and then I work out a. First, we are going to move this positive 8 over to the other side of the equation. It becomes negative 8, and that will give us negative 2 on the left hand side. And then on the right hand side, that a can stay there. 0 minus 1 will just give me minus 1, and if I square that, it just gives me 1, and 1 times a is just a, so we get a to be negative 2. Now I'm going to grab that a value and I'm going to sub it back into this original line to get a new line that looks like this, where I have the negative 2 replacing a in this line. And now the square is talking to me, but it's telling me to write the bracket twice, my bro. So we're going to write the bracket twice so that we can FOIL. We FOIL out these brackets to get x squared minus 2x plus 1. And now we're going to get this negative 2 in the bracket by distributing it to all three terms. And after we do that, we get minus 2x squared plus 4x minus 2. And we have that plus 8 chilling at the end. And minus 2 plus 8 gives us 6. So we've officially arrived at the final answer. Check there. J of x minus 2x squared plus 4x plus 6 minus 2x squared plus 4x plus 6. And the slagmense only award 3 marks over here. 1 for your substitution of both the turning point and this coordinate. 2nd for your value of a. And 3rd for your correct simplification. In the next question, we need to calculate the average gradients of j between the x value of 1 and the x value of 3. To calculate average gradients, we just use our gradient formula. So we're going to need 2 points, and they're specifying the points here. So they want the points at x equals 1. Do we have that point? We do indeed. It's t. So we have the first point that we're going to put into the gradient formula. But we don't quite have the second point. I mean, we have like half of it. We've got the x value. So to get the y value, we need to sub it into the respective graph. So we're going to sub it in our blue graph because we're getting the average gradients of j in the blue graph. So we're going to start off that process by saying j of 3. Instead of saying j of x, I'm replacing all the x's with a 3. And that's exactly what I do in this next step here. I just replace all my x's with 3's. You can see 3's have replaced these x's. Okay, let's go ahead and chuck that in the calculator. Alrighty, Dr. Calculator, how's it, brother? Underbut. Okay, so j of 3 is 0. So that tells me that the y value is 0. So this point is actually the point Q. Okay, so now we know the other points that we will be putting into our gradient formula. So let's chuck these guys in. I think I'll just put t in the blue guy's place. Just remember the y values go on top. I'll put q in the pink guy's place. And then ain't nobody got time for that, bro. That's going straight in the calculator, bro. So if we just slap it in there, it gives us -4. So the gradient, or the average gradient of our graph between x equals 1 and x equals 3 is -4. It's a straight line that's drawn through t and q. Okay, let's have a look where our 3 marks are coming from. First mark comes from the correct coordinates or points. Second mark for your substitution. Third mark for the final answer. In question 8.3, we need to get the coordinates of P, which is a point of intersection of J and K. And to get points of intersection, you simply equate the two graphs. So we make the parabola's equation equal to the straight line's equation. And now to start working on this fraction over here is really bugging me. So I want to get rid of it quickly. And to do that, I'm going to have to times by 3. But if I times that term by 3, I'm going to have to times every single term by 3. Okay, so if we go ahead and do that quickly, we're going to get minus 6x squared. 4 times 3 will give you 12. 6 times 3 will give you this 18. The third times 3 gives you 1, so you get 1x, and 1 times 3 will give us 3 over there. And now to start solving, you can see that we have a quadratic equation. So we need our standard form, so we're going to get everything to one side and make it equal 0. So I'll start with the x squared term, this minus 6x, move it over to that side, and it becomes positive 6x. And then let's do the x's. So we're going to move this 12x over to that side. It becomes minus 12x. 1x minus 12x will give me minus 11x in the middle. And then if I move this 18 over, it becomes minus 18. Minus 3 minus 18 gives me this minus 21 at the end here. Now we've got the laborious task of factorizing this bloody trinomial. And to start off that process, we are going to set up the tennis court method. So I'm going to write the factors of 6 underneath each other in the front over here. So we can try 1 and 6 or 2 and 3. I'm going to start off with 1 and 6. And then we also use the factors of 21 over here. I'm going to try 3 and 7 to start off with. And then I multiply going across the court. So 6 times 3 will give me 18. And 1 times 7 will give me 7. Now I need to add or subtract these two numbers to get this minus 11 in the middle. And I think I can get that done by saying minus 18 plus 7. And then we transfer those signs back in. And these form our two brackets. Our first bracket, we just chuck a little x here, chuck a little x here. And then my first bracket will be x minus 3 over here when I factorize the trinomial. Then my second bracket will be 6x plus 7, which I will put over here. And from these two brackets, we're going to get our two answers. This one will return us an answer of positive 3, because if I made that factor equal to 0, take the minus 3 over. This factor over here will return us an answer of minus 7 over 6. Take the 7 over, becomes minus 7, divide through by that 6, and you get minus 7 over 6. Now we've got to decide which one belongs to P and which one belongs to Q. Okay, that's quite a clear-cut decision. We can already see Q is 3. So we're going to put a stroke through the equal sign here because we're not using that one. We're interested in the coordinates of P. So this one is relevant to us. Now we've got like half of P. We have its x value. And if I'm missing the y value, if I'm missing its partner, all I need to do is sub this in to get it. So I can sub it into the blue graph or the green graph. This point lies on both of them. The green graph looks a little bit easier to me, so I'm going to substitute it into that graph. So I just replace x with my x value here. We're going to chuck that in the calculator, and we get minus 25 over 18. And now we have the coordinates of P to be minus 7 over 6 and minus 25 over 18. And your 5 marks will be earned from equating the two graphs, standard form, factors, answers with the exclusion as well as the correct y value. In question 8.4, we need to get the maximum length of VW. So what we do is we have a look at VW and we recognize which graph is on top and which graph is at the bottom. And then we get an expression for VW by saying the top graph minus the bottom graph. And then when you minus the bottom graph, do not forget brackets. That is crucially important. And now just bear in mind this process only works for perfectly vertical lines. At the beginning of the question, they told us that VW is parallel to the y-axis, which is a sneaky way of telling you it's a perfectly vertical line. And the first thing we're going to do to start simplifying is distribute this negative into that bracket to get rid of it. Okay, then we're going to do our like terms. So we're going to do 4x minus a third x. The minus 2x squared will just stay in the front, by the way. And then, I'm going to use my calculator to help me out with that one. Hey? I don't want to work with fractions, don't want to waste time doing that. So it's always better just to pop it in the calculator. It gives us 11 over 3. So in the middle we get plus 11 over 3x, and 6 plus 1 will give me the 7 over here. Now next up we need to get the turning point of this expression for VW. So I'm going to use my magic formula. The turning point formula minus b over 2a. Right, so let's chuck in all our goodies. B is the number in front of x, so it's this 11 over 3, so it's the minus version of that. And then a is the number in front of x squared, so it's this minus 2 over here. That goes straight in your calculator and returns you a value of 11 over 12. And then I grab this 11 over 12, I substitute it back into this line for VW, and we get our substitution step as follows. Type that in the calculator, and we get 625 over 72 units, which is about 8,68 units. And there's your max length of VW. And your 4 marks are earned from the correct method being applied, your simplification, the correct method to get the turning point, as well as the correct answer. In question 8.5, I need to use the graphs to determine where j increases, and we just state x values for our answers. So j belongs to the parabola, so we're going to ignore the straight line for this question. And intervals of increase and decrease all revolve around the x value of your turning point. And the trick is to read your graph from left to right. So I start all the way on the left, and if I go on top of this graph, you pretend like you're driving on it. You can see you're going uphill. So that over there is an interval of increase. So every x value that's smaller than 1, your parabola is increasing. Then as we cross the turning point, so as our x values get bigger than 1, our graph will start to decrease. So they want the interval of increase, so we're just going to state whenever x is smaller than 1, our parabola increases. And another notation is possible. You can say like from minus infinity all the way up to 1, and then we use circular brackets. We don't include the turning points because it neither increases nor decreases at that point. Okay, the next question is a very tough one. We're going to start off by dividing both sides by a negative, because this negative here is making our lives very complicated. So let's divide both sides by a negative. So on the left hand side, these negatives will cancel, and it will just leave us with j of x over k of x. And then on this side, we can see that the inequality has swapped directions. 0 divided by negative 1 is just 0, by the way. And the inequality swaps direction because I divided by a negative. Don't forget that small rule. Ooh, and now to analyze this inequality. So they're asking you, where is the y value of the blue graph divided by the y value of the green graph give you a positive number? Anything that's bigger than 0 is positive. And we can get that by saying a negative over a negative, or we can say a positive divided by a positive. Now your best strategy to do this is to draw vertical lines through all the x-intercepts you can find. It doesn't matter if it belongs to the green or the blue graph, but I'm going to draw vertical lines through my x-intercepts, r and q. And then on either side of those lines, I draw a little vertical line. So I draw a little vertical line here, and then I'm going to draw a little vertical line in the middle of the gray lines. So I'm going to draw one there, and then I'm going to draw a little vertical line over here. And now I can analyze, basically, you see there I have a negative y value, and there I have a negative y value. So I've got a negative divided by a negative, so it's actually working in this region here. So it's working whenever x is smaller than -1. Okay, over here in the middle, I have a positive y value. You can see that it's a positive y value because it's above the x-axis, being divided by a negative y value. So that's not working. It's not giving me one of the two cases I want. And then if I cross this x-intercept, I've got a positive y value over there because it's above the x-axis. And I've got a negative y value there for the blue graph. So I'm going to get a positive divided by a negative, or the other way around. So that won't work. So the only place it's working is over there. And we simply just write that like this. X is smaller than -1. And now we just quickly have to address this equals to symbol. So we've got to be careful at this point over here. So the blue graph is on top in this inequality. Okay, so we actually safe to include -1. And that's because I'll get 0 on top of the fraction. So I'll get 0 on top here and some negative number. I think we actually even got it in the previous question. So I'll get 0 divided by a negative number, which will give me 0, and it will work. If the bottom was 0, I'd have to exclude it, if you know what I mean. Okay, let's have a look where our 3 marks come from. All 3 marks are simply just awarded to your answers in this case. Wrapping up question 8. For which values of k will j of x minus k have 2 distinct roots? So the first thing we do is we're going to take this negative k over to the other side of the equation so that we get j of x is equal to k. Then what we have to do is kind of picture k to be a horizontal line. And I can place this horizontal line in 3 specific spots over here. So I can firstly place it anywhere above 8, and then it will not touch my parabola. And then I can place it exactly on 8, and then it touches my parabola once over here, and we regard that as equal roots. And the other place I can put it is below 8. And when I put this line below 8, I'm going to get 2 separate roots. Now what's important to realize with these questions is the intersection points between your parabola j and this horizontal line k are the roots they're actually talking about. So they want you to place this line so that you get 2 unequal, aka distinct roots. So they want you to place the line anywhere below 8 to get those 2 points of intersection, aka roots. So our answer is simply just whenever k is smaller than 8. And you simply just get 2 marks for your answer in this question. In question 9, we start off with our probability. And we are going to be doing a probability tree for Who Wants to Be a Millionaire, which is a very popular game show. I don't know if you know it. It was hosted by like Jeremy Clarkson and Chris Tarrant. And they ask you like a bunch of questions, and if you get the question wrong, your game is over. So all our rules have been listed over here. So during the first round of questions, 3 possible things can happen first. I can either answer the question correctly, or I can answer the question incorrectly and my game is over. Or I can take option 3 and use a lifeline, which is like a clue or a little bit of help for you to get the right answer. Then after I use a lifeline, I have to answer the question, so I can either answer it correctly or I can answer it incorrectly after using the lifeline. Now we've got to fill in the probabilities over here. The probability that Jeremy answers the question correctly on his own, that implies without the lifeline, is 0.7. So this branch over here will get a 0.7. And then the probability of answering it incorrectly is 0.1. So this branch will get a 0.1. And then the probability to use a lifeline is 0.2. So we've got a 0.2 on this branch over here. And then after using the lifeline, to the probability of getting it correct, let's have a look here. Uses the lifeline. The probability that he produces the correct answer is 0.9. So this branch will get a 0.9, which means that the branch below will be 0.1 because we use the complement rule. These two numbers must add up to 100%. So if he's got a 90% chance of getting it correct, he's got a 10% chance of getting it incorrect. Now we're going to have a look at the second round. Okay, so if he answers it incorrectly, his game is over. So there's no branches after the I's because his game is over. He goes home. Okay, so we're only going to have branches after the C's. So this C over here, I've used the lifeline already, so I can't use another lifeline. So I've only got two options. I can get the answer correct or incorrect. And just for reference sake, you may only use a lifeline once. I used it in the first round over there, so I can't use it in the second round. And let's fill in the probabilities of those. So the chances he gets it correct on his own without a lifeline is 0.7 and incorrect is 0.1. Now we also continue into the second round if we get it correct straight away. And then I have three possible outcomes as to what can happen. I can either get the answer correct, incorrect, or use a lifeline. And then after I use a lifeline, I can get it incorrect or correct. So we have finished our probability tree now. Let's just quickly review how I got these numbers over here. Pretty much the exact same three as these. And then over here, we've got the same as this. So it's almost like a copy paste of this first branch over here. And for this question, you're going to get 1 mark for the second round and 1 mark for the first round. In 9.2, we need to determine the probability that Jeremy will, unassisted, answer the first 2 questions correctly. So we are going to follow this purple branch over here. He gets it correct and then correct. And if I'm finding branches, I multiply the probabilities. So our probability will just be 0.7 times 0.7. We pop that in our calculator to get 0.049. And 2 marks are awarded for each of the following steps. In 9.3, we need to determine the probability that Jeremy answers the first question correctly. So we're only in the first round. So we're going to ignore the second round. And now I can see 2 branches where he answers the first question correctly. He can use a lifeline and then get it correct. So in this blue branch, he gets it correct. And then he can just answer it correctly straight away if he's a smart cookie. So the green branch, he also gets it correct. So to get the probability of that, we need to add together the probabilities of each branch. So we're just going to pop in the relevant numbers. The probability of the green branch is 0.7. And the probability of the blue branch, if I'm going across little arms like that, I've got to multiply their probabilities. So it's going to be 0.2 times 0.9. And then we slot that in the calculator, and he gives us a toasty little 0.88 bot. And your 3 marks come from the correct probability for the green branch, adding the correct probability for the blue branch, as well as the final answer. In question 10, we are given 3 events, A, B, and C. We are told that A and B are independent. B and C are also independent. A and C are mutually exclusive, and we've been given all 3 of their probabilities over here. And we need to calculate the probability of both events A and C occurring. So we will be calculating the probability of A and C. And they told us that A and C are mutually exclusive. Now let's quickly go over what mutually exclusive means. It means it's impossible for them to happen at the same time. So the probability of A and C happening at the same time is a crispy little 0. And that is something you've just got to know off by heart. and your 1 mark just gets awarded for that 0 over there. In the next question, we need to get the probability that both B and C occur. So we will be working out, and we were told that B and C are independent events. So if we have independent events, we can just multiply the separate probabilities together. The probability of B times the probability of C. You can only do that if they are independent events, and this formula is not on the formula sheets. Okay, so the probability of B is 0.4. So let's go ahead and change that quick. And the probability of C is 0.2. And then we can just pop that in our calculator, press equals, and we'll get 0.08 as our final answer. And your 2 marks come from substitution and answer, and bear in mind if you gave the answer only, full marks. And in 10.1.3, we need to calculate the probability of at least one of A or B occurring, which is asking you to calculate the probability of A or B. And we're going to do that using our classic probability formula, where you add the probabilities and then subtract the probability of them both happening at the same time. Okay, so let's see what we know about events A and B. A and B are independent. By telling me that small word, that gives me a way to work this out. Because for independent events, I know a special formula. I know to get the probability of A and B, I can just multiply their probabilities together. So I can just multiply these two numbers together to get that probability of A and B. So let's go ahead and change everything. Okay, so let's start off in this formula. Probability of A 0.3, probability of B 0.4. So if we make that change and then multiply them together on our calculator, we're going to get 0.12. Now we have all the goodies we need. Let's pop them in. So the probability of A is 0.3. Probability of B is 0.4. And the probability of A and B, we worked it out to be 0.12. Okay, slap that in your calculator and you get 0.58 as our final answer. And your 4 marks are awarded for the substitution and answer here, as well as the substitution and answer here with the probability formula. In question 10.3, we've been given the length of 80 worms. 2 worms are chosen at random, and we need to determine the probability that one worm is 5 centimeters or shorter and the other worm is longer than 15 centimeters. And we are going to color code these 2 events just so we know what's going on. A worm shorter than 5 centimeters is represented in orange. Longer than 15 will be these guys, because that's 15 to 20 centimeters. So we have 25 worms that are longer than 15 centimeters. 17 plus 8 gives me 25 worms. So now I'm going to draw a quick tree diagram to help you understand what's happening. So I'm going to choose my first worm. Now the chance that I choose a long worm is 25 over 80. And then after that, I could choose the short worm. Now I don't have 80 worms anymore. I've only got 79 left because I chose one over here. And then I've still got 9 short sort of worms. So I still have a probability of 9 on top there. The other probability is I choose a short worm first. And in that case, I have a probability of 9 over 80, which is my sample space of how many worms there are. I chose a short worm, so there's only 79 worms left, and there's 25 long worms. So we need to add together the probability of these 2 branches. So if I go across this branch, I multiply their numbers over here. So I say that 9 over 80 times 25 over 79. Sorry, I'm doing this bottom branch first here. And then the second one, I add it, and that's going to be 25 over 80 times 9 over 79. Okay, and then you just slant that in your calculator, and we're going to get the probability to be 0.07. And your 2 marks in this question come from the substitution as well as the final answer.